I'm gonna launch my boat. Yes. Oh, I need to attract this metal with my magnet. Let me put some electricity in it. Oh, what happens if I turn it off? Oh, the metal's gone. Oh my goodness. I wonder what this magnet is. This is an electromagnet, a temporary magnet that has a magnetic field because of an electric current running through it. The battery is a source of electrons for the magnet. The battery, the conductive wires, and the ferromagnetic nail create a circuit. And as the electrons, which act as tiny magnets, cycle through the circuit, they create a magnetic field, which allows the nail to pick up things like paper clips. Well, I'm not going to be picking up paper clips all the time. I wonder if there's any like real life applications for oh my god. Real life applications. Electromagnets are actually used in a lot of different things in real life. Speakers, EVs, MRI scanners, maglev trains, even some things that are less than innocent. And I know what you're probably thinking. Norrin, how are magnetism and electricity interconnected? Well, I was just about to get to that. Number 1. Electricity is a phenomenon associated with either stationary or moving electric charges, and magnetism is defined as a physical phenomenon produced by moving electric charges. You can have an electrical field without a magnetic field, and vice versa, but a moving electrical charge always has an associated magnetic field, while permanent magnets have magnetic field without an electrical current. If you haven't already noticed, electricity can be made with magnets, and magnets can be made with electricity. Basically, both electricity and magnetism are built on the electric charges of particles. But while electricity is built mainly on the charges of the particles themselves, magnetism focuses more on the attraction caused by the difference in moving charges of the particles. Okay, that's enough about the inner workings. I just want to build something. What would be cool to build? Cars! Cars have motors in them. Let's make an electromagnetic motor. Alright, first we're going to need a few things. A battery, a permanent magnet, a small one, 2 ferromagnetic paper clips, some copper magnetic wire, and some electrical tape, and then maybe a marker to coil the copper wire around, and either tape or some Play-Doh to hold the battery in place. Alright, so first you're going to want to bend both paper clips so that they both end up looking like this. Then you'll attach both paper clips to both sides of the battery, making sure that they touch their respective poles and protrude from the battery, especially on one side. After attaching what you've got so far to your surface, this is what it should look like. Next, you're going to take the marker and the wire and coil the wire around the marker 10 times so that it has an even circle in the middle and 2 protruding ends on the other sides. This is what the wire should look like once you're done. Next, you're going to need to sand the wire so that one end is fully sanded and the copper is completely exposed, and the other end is only halfway sanded and the copper is only halfway exposed. After sanding, the wire should look like this, with one side fully exposed and the other side halfway exposed. Now, you're going to take the coil and place it into the little holes in the paper clip, making sure that the arms stay straight, unlike in the video. Then simply slide the magnet inside and give it a spin. Like I said, if everything is in place and you give it a nudge, the motor should start spinning all by itself. And the motor spins because of the way that we sanded the wire. When the bare copper on both sides of the wire is touching the paper clips, the coil becomes an electromagnet. But since it's only halfway sanded on one of the sides, it's only an electromagnet every time both sides are touching. So it turns on and off as it spins. Since it's an electromagnet, when it is on, it pushes off of the magnetic field of the permanent magnet that's on top of the battery. And then, once it turns off, there's no longer a push. The turning on and off of the electromagnet is essential to the spinning of the motor.
I see space.
Wow. Here's my sources. Thanks for watching.